Example 1. The following graph compares ice cream sales and temperature outside. The line of best fit is drawn for you. So we have our independent variable of temperature in degrees Celsius and our dependent variable, which is the sales of ice cream. The line of best fit is already there, and we can see that there's a strong positive correlation. So it's strong because the points are close together. It's positive because the line is going up. We learned that a while back, the vocabulary of strong, positive. And now we can connect it to slope because remember, we also learned that when it goes up, the slope is positive. So that's why we call it a positive relationship, because it's going up and the slope is positive. So we are being asked to determine the equation that represents the line of best fit. In order to write an equation, I want it to be in the form y equals mx plus b, which means I need to find the slope and the y-intercept of the line. And in this case, I'm going to do that by finding 2 points that are on the line and using them to find the slope. And then I'm going to find the y-intercept after that. So it can be any 2 points anywhere on the line. You'll notice that some of our data points actually go through the line or kind of beside the line. So we can use our data points. If I wanted to, I could have used these 2 points right here because they are both part of our data and they look like they're fairly close enough on the line, these 2 right here. I could have used this one, could use this one, it really doesn't matter. Or you can just pick any random point, or not random, but any point anywhere on the graph. So what I'm actually going to do is just to show you, I'm going to pick 1 point that actually is part of our data set. So I'll pick this one right here. This is one of the points I'm going to use. And the other point I'm going to use, I'm just going to pick something somewhere else on the line. So I'll pick this over here. And it's okay that it's not part of our data, because at this point, imagine that everything else fades and I'm just looking at this line of best fit. That's really all I care about right now. I'm writing the equation of this line. So any 2 points anywhere on the line, I can use them. So I'm going to use these 2. So the coordinates of this first one over here, well, the x value, the x's go up by 2's. So it looks like it's between 16 and 18. Halfway is 17, but it's not quite there yet. So it looks like it's between 16 and 17. So I'm going to say that it's 16.5. And the y value, it's between 300 and 400. It's not quite halfway. Halfway would be 350. It looks like it's halfway of that, maybe even a little bit lower. So I'm going to say 320. So that's my coordinate here. The coordinate of this other point on the line that I just selected, it's not part of our data, is 20. And the reason I picked this one was because it's nicely on the line, so it's easy for me to see that it's 20. And the y value, if I go across this way, it looks like it's halfway between 400 and 500, so I'm going to say 450. Okay, so now I have my 2 coordinates that I'm going to use to find my equation. Okay, so I'm going to write them down here. They are 16.5, 320, and 20, 450. So in order to find the equation of a line, I need to first find the slope. And in order to find slope, I'm going to use the formula y2 minus y1 over x2 minus x1. And I'll label, this is going to be my first equation, x1, y1, and this is going to be my second equation, x2, y2. I'm going to substitute these known values into the equation. So y2 was 450, y1 is 320, x2 was 20, and x1 is 16.5. Okay, I've ran out of space, so I'm just going to draw an arrow that looks like this, and I'm going to continue writing over here. That's actually proper math form, this arrow, and it indicates that I'm continuing my calculations. Oh, sorry if you can't see. Oh, there you go. And it indicates that I'm continuing my calculations over here. Okay, so I'm going to simplify. 450 minus 320 is 50, 70, 120. Over 20 minus 16 is 3.5. Okay, and I'm actually going to write my answer as a decimal. So I'm going to enter, oh, this is actually supposed to be, my bad. 130 divided by 3.5 gives me 37.1. So that's my slope. That dot here means approximately 37.1. My y-intercept. So I'm going to use my slope, which is 37.1, and I'm going to use either of these points. I'll use this one. Actually, it really doesn't matter. 20, 450. So this is my x value and my y value. So I'm going to substitute that into the y equals mx plus b equation. Y was 450. M is 37.1. And x is 20. 37.1 times 20 gives me 742. Okay, then I'm going to bring this over to the other side. Just going to squeeze in. Becomes negative. And I put that into the calculator. So 450 minus 742 gives me negative 292. Okay, so that means I should write it down here, but I just don't have enough space, so I'm going to put it up here. Therefore, the equation is y equals m, which is 37.1, x plus, minus 292. Okay, so now I'm going to use that equation, and it looks a little bit misleading if you look at the graph, because this is negative. Remember, this is our y-intercept, so it implies that it's going to cross the y-axis at negative 292. But this graph, no bueno. Look what they did. They started off at 10. This should not be. So I noticed that a lot of you guys did that in class. You started off here, but this value here should actually be 0. They should not be starting this graph off at 10 because it throws off the values. So they didn't graph this properly. That's why if I were to add another 10, the line would actually go down and go into the negatives, which means if x is 0, if I'm not selling any ice cream, I'm actually losing money because I've spent money on materials, but I'm not gaining any profit. Okay, so now let's use this equation to figure out what the ice cream sales would be approximately if the temperature was 30 degrees outside. So I'm going to take the equation. Y equals 37.1x minus 292. And I'm going to substitute x is equal to 30. Okay, so BEDMAS, I'm going to do multiplication first. So 37.1 times 30 gives me 1,113 minus 292, which gives me $821. So therefore, the sales would be $821 approximately. And it's approximate because we had rounded this value up here, so it's an approximation.